Number 4, 2016. A company manufactures model rockets that require igniters to launch. Once an igniter is used to launch a rocket, the igniter cannot be reused. Sometimes the igniter fails to operate correctly and the rocket does not launch. The company estimates that the overall failure rate, defined as the percent of all igniters that will fail to operate correctly, is 15%. So I'm just going to write that down here. The probability that the igniter fails is 0.15. It says, a company engineer develops a new igniter called the superigniter, and with the intent of lowering the failure rate. So to test the performance of the superigniters, he uses the following process. Step 1, pick a superigniter at random and use it in the rocket. If the rocket goes off, the superigniter selected at random and used in a rocket. Step 2, repeat the process until it stops. So it's like you keep playing the game, and if it works, you get to play another round. And if it works, you play another round. And the process stops when either one of the superigniters fails to operate or you win the game, so to say, the rocket launches 32 times in a row, whichever comes first. And assume that superigniter failures, this is an important line, are independent. That means that each superigniter does not affect the others. A, if the failure rate of the superigniters is 15%, what is the probability that the first 30 superigniters selected from the testing process work? What's the likelihood that 30 in a row work? Well, if the probability of failure is 15%, that means the probability of success, that the rocket goes off, is 0.85, since those are really the only two options here. So what would be the probability? A says, what's the probability that 30 successes in a row? Right? Think of it like flipping a coin. Those events are independent. What's the likelihood of getting heads 30 times in a row? It's 0.5 times 0.5 times 0.5 30 times. Well, what's the probability of it working 30 times in a row? Well, that's 0.85 to the 30th power. You multiply 0.85 30 times and you get 0.0076. So it's only about a 0.76% chance of that happening. Part B, given that the first 30 superigniters worked, what is the probability that the first failure occurs on the 31st or the 32nd try if the failure rate is 15%? So now it's saying forget the first 30 steps. The first 30 already happened and they all worked. Part B says, what is the probability that the 31st fails? Well, remember that they're independent events and the first 30 already happened, so what's the likelihood it fails on the 31st try? 0.15, that's it. No tricks, it's just that attempt is an independent attempt. Now, the next one's a little trickier. The next one says, what's the probability that the 31st is a success and the 32nd fails? Well, what's the likelihood the 31st works? First, that would be 0.85. What's the likelihood that the 32nd fails? Independent event, so 0.15, multiply them. And the likelihood that the 31st, assuming that the first 30 already happened and they all worked, the 31st works and the 32nd doesn't, 0.1275. Okay, now part C. Part C says, given that the first 30 superigniters successfully launch rockets, is it reasonable to believe that the failure rate of the superigniters is less than 15%? And explain. Okay, so for here you got to write a little bit, but think about it this way. If it did fail at a 15% rate, then the likelihood of winning 30 times in a row, we already answered this, is only 0.0076 or 0.76%. And that's really, really unlikely to happen. What would happen if you raised the success rate or decreased the failure rate? Then it would make more sense that this were to happen. Say it was like 90% and 10%. If you did 0.9 to the 30th, it's going to be a larger likelihood. So really, we have some good evidence that maybe 15% is wrong. Maybe that's actually too high, which kind of makes sense because that's the probability they had for the old igniters, but these are superigniters that should work better. So yeah, we do have reason to believe that the superigniter failure rate is less than 15%. So I'm going to write this out, and I'm going to write In part A, we found the likelihood of 30 launching in a row, assuming, 1m and assuming, that 15% is the true failure rate, is only 0.76%. Being less than 1%, it would make sense that the true failure rate is actually less than 15%. Okay?